So we are solving equations by factoring. What we're looking at is we're solving quadratic equations here. So anything with an x squared, we're working on solving. The difference between factoring and then solving is just an equal sign. So that's our fill in the blank right here. Okay, so to solve the equations by factoring, what we want to do is we want to set the equation equal to 0. Then set the factors equal to 0. And then we solve. Okay, so for our first example, we have our steps on the right side. So we have 8r cubed plus 16r squared equals 64r. So the first step is we want to set the equation equal to 0, which means we want to just move everything to one side of the equation. And sometimes we have to distribute and simplify to do that. So on my right side, I have the 64r. I'm going to subtract it over to my left side. It doesn't combine with anything, so I just end up writing everything next to each other. So I go 8r cubed plus 16r squared minus 64r equals, and then on this side, these guys cancel each other out, so that will equal 0. Then step 2 is we go through the factoring piece of this. So we always look for a GCF first. So I'm going to look at my numbers. 8, 16, and 64, they seem like they're all divisible by a number. What would that be? Yeah, I think they're all divisible by 8. And then what we have the r's. We've got at least 1 in each of them. So I think I can take a GCF of 8r out of each of these. All right, so that'll give us an 8r, and then let's see, 8r cubed divided by 8r. 8s are going to cancel. R to the 3 minus 1 will give us an r squared. 16 divided by 8 will give us 2. R to the 2 minus 1 will give us just r to the first. R's are going to cancel here, and 64 divided by 8 is going to give us a negative 8. Okay, I'm still factoring. So now I want to look inside r squared plus 2r minus 8. That is a monic trinomial, so I'm going to set it up with my 2 parentheses. I'm going to put an r into each one of these. And then I'm going to look for factors of 8 that combine to 2. So let me see here. I've got 1 times 8, 2 times 4. Can we think of a combination that we will multiply to negative 8? So we need 1 positive, 1 negative, and add to positive 2. Yeah, positive 4, negative 2. 4 minus 2. So r minus 2, r plus 4. Negative 2 times 4, negative 8. Negative 2 plus 4, positive 2. 8r is also still a factor, and you want to bring down this equals 0. Okay, so that's all step 2. So now we want to go to step 3, set each factor equal to 0. Now here I have 3 factors. My first factor is this 8r, so I'm going to go 8r equals 0. My second factor is r minus 2, so I have r minus 2 equals 0. My third factor is r plus 4, so I have r plus 4 equals 0. And then I'm going to solve each of these equations. So I'm actually going to have 3 answers to my problem. Okay, so here I have divide by 8. 0 divided by 8 is just going to be 0. That's my first answer. Then here I'm going to add 2. 0 plus 2 is going to give me 2. And then here I'm going to subtract 4. 0 minus 4 is going to give me negative 4. So I have 3 answers. Or we could write it like this. R equals 0, 2, negative 4. Okay, the reason why I know there's going to be 3 answers, so you can always tell how many solutions that you're going to have by looking at your original problem and looking at the degree of the problem. So that has a degree of 3. there's going to be 3 solutions. Now, what this tells us with these solutions is that if I plug each of these in, I should be able to get a true statement. So let me get my calculator here. Now, just looking at 0, since there's an r on each term, 0 will work. If I plug a positive 2 in here, I have 8 times 2 cubed plus 16 times 2 squared minus 64 times 2, or I can do the original one. That gives me 0. And it should be the same thing with negative 4. Negative 4 cubed plus 16 times negative 4 squared minus 64 times negative 4. And that also gives me 0. And then just to check, 8 times 0 squared, or cubed, sorry, plus 16 times 0 squared minus 64 times 0 also gives us 0. So that's how we can check the solutions to our problem. So you're really just, all of it is the same that we've been doing with factoring. You're just taking it one step further and solving each factor. Okay, so let's take a look at example 2. So example 2, we want to get everything to one side first. So in order to do that here, I am going to have to do some distributing. So let's see, I'm going to do 2z times 4z. That is going to give me an 8z squared. 2z times 11 will give me a 22z. And I see what's happening here. Okay, so let's move everything to one side. So let's say I'm going to move over to the right. I'm going to take the 8z squared, subtract it from both sides. I have to subtract it from the other z squared term. I also have to take the 22z, subtract that. I'm going to subtract that from the other z term. So what ends up happening, here's my equal sign, is these cancel, and this gives me 0, but this also cancels, and I get negative 1. Well, does 0 equal negative 1? No, it does not. That's a false statement. 0 does not equal negative 1. When you get a false statement, what do we say? No solution. Good. Okay, so if I get a false statement and things cancel out, that is a no solution problem. Okay, let's take a look at example 3. So here I have 16x cubed minus 24x. So I should have 3 x's. Just looking at that first, so 3 answers. Now it's only 2 terms. It's already set equal to 0. It's 2 terms. I'm thinking, okay, maybe this is a perfect square, difference of squares. But 24 is not a perfect square. But 16 and 24, those were both divisible by what? 4 or 8, right? I think either one would work. Okay, let's do the biggest one. So these are both divisible by 8, and they both have an x. Okay, so 16 divided by 8 is going to give me a 2. And then x to the 3 minus 1 will give me x squared. Then 24 divided by 8 will give me 3. And these x's are going to cancel. Okay, then I had the 8x over here. Okay, I don't know if this example was supposed to have the x cubed in it because we're getting to that, I think, in the next chapter, but that's okay. We can keep doing this. All right, so we want to take each of these factors, set them equal to 0. Now this one, can I factor that further? No, I can't because those aren't perfect squares. So that's not a difference of squares. So I'm going to have to just go ahead and solve that, which is fine because I only have an x in one spot. So that's okay. So I'm going to take my first one, 8x, okay, and set that equal to 0. Then I'm going to take the 2x squared minus 3 and set that equal to 0. So for the 8x, I'm going to just divide by 8, and 0 divided by 8 is 0. So I get an answer of x equals 0. Now here, I am going to add 3 to both sides. That's going to give me a 2x squared equals 3. Then I'm going to divide by 2. And that's going to give me x squared equals 3 over 2. All right, now when I'm solving quadratics, which we're going to do, I think, in Module 3 here, so we're looking ahead a little bit. When I'm solving a quadratic with an x squared, how do you suppose we undo the x squared? So let's think about this. If I just do 2x, I undo that by dividing, because dividing is the opposite of multiplying. So it would be the opposite of squaring. Square root. Very good. So here, if I want to undo this, I can just take the square root. Now, when I take the square root, okay, remember, it's the number times itself, and a positive times a positive is a positive, and a negative times a negative is a positive as well. So when I take a square root, I've got to do a plus or minus sign in front of it. So there's actually two answers here. You have plus the square root of 3 over 2, and then negative square root of 3 over 2. And we're not going to actually get that number, okay? So we're just going to say it's positive square root of 3 over 2, and then negative square root of 3 over 2. We're going to leave it like that, simplified. Okay, because this is probably a pretty yucky number here. Not a fun number. But if I want to check this, 16, then let's take my answer, cubed minus 24 times that answer should give me 0. And it does. Okay, now typically I think if that was just 2x equals 3, then the answer would just be 3 over 2. But I think I accidentally put an extra x in there for you guys. Any questions on that one? All right, so let's look at example 4. Okay, so let's get everything on one side here. So I'm going to move everything to the left. I'm going to take the 6y squared, that'll subtract, and the minus 6 will add. So that means I'm going to have this, y cubed, then minus 6y squared, then minus y plus 6. I'm just putting these in order with the y's. And then that equals 0. All right, 4 terms, so I'm going to factor by grouping. So I'm going to split right there in the middle. I'm going to take a GCF out of each, so 4 terms. Equals factor by grouping. Okay, what can I take out of y cubed minus 6y squared? Y squared. All right, so let's see what that gives us. Y squared, y cubed over y squared, that'll give us y, and minus 6. What can I take out of minus y plus 6? Negative 1. Remember, if you can't take anything, take a 1. And then if you need to change the signs, which here we do, take a minus 1. And then that'll give us a positive y, negative 6. All right, so one of my factors is y minus 6. My other factor is y squared minus 1. Okay, you could solve the y squared minus 1 the way we did in the previous example, but could I factor this further? I'm seeing some yes and some no. So you can. 1 is a perfect square. A lot of people tend to forget that. 1 times 1 is 1. So this is actually a difference of squares. So this actually factors to y minus 1, y plus 1, then y minus 6. Okay, so in this one, I can actually factor that further. And then I'm going to take each factor and I'm going to set it equal to 0. And once you guys get the hang of this, you kind of see it just as the opposite. So y minus 1 equals 0. I'll add 1 to both sides. 0 plus 1 gives me 1. So I get y equals 1. Then y plus 1 equals 0. If I subtract 1, that's going to give me a y equals negative 1. And then y minus 6 equals 0. I'm going to add 6. 0 plus 6 gives me 6. So I have 3 solutions here. 1, negative 1, and 6. And then you can go through and check it if you would like. And you also could have done y squared minus 1 equals 0. Just to show you guys. You could have gone y squared minus 1 and then added the 1 and then take the square root. And the square root of 1 is 1. So you do plus or minus. See, the thing is, I don't like you guys doing that because a lot of you forget the plus or minus. But that still gives you the same thing, positive 1 and negative 1. Okay, does anyone need to see over here again? All right. All right, so let's look at example 5. So you have a quadratic problem with fractions. It's already set equal to 0 though, so that's good news. Let's get rid of the fractions. What's the common denominator? 4. 4, yeah. You want the biggest one. If I multiply by 2, this is still going to be a fraction. So we want 4. So let's multiply everything by 4. Even the 0. All right, so here these 4's cancel. That's going to be x squared. Here 2 goes into 4 2 times. So 5x times 2 is 10x, and that looks like that is a minus sign. 6 times 4 is 24. 0 times 4 is 0. Okay, monic trinomial. So I'll set up my x's. Do I have any numbers that multiply to 24 and add to 10? I got 1. 2 and 12 might work. 3 and 8, no, that's 11. 4 and 6, that could work also. And that's it. So the question is, it's a positive 24. We want to add 2. No, that's 14. 2 plus 12 is 14. Now, if it was negative 24, then we would want a 2 minus 12 or 12 minus 2, right? But this is positive, so we want them the same sign. So negative 4, negative 6, that gives us negative 10. But it will multiply to a positive number. Okay, so we want to be careful with those because that has 2 combinations, again, like the 6, that could combine to 24, or sorry, 10. You just have to check the signs. So if it's a positive, they have to be the same sign. When it's positive, you add the factors. When it's negative, you want to subtract the factors. Okay, then we take each of these factors, we set equal to 0. So x minus 4 equals 0. I'll add 4. And that'll give me an x equals 4. X minus 6 equals 0. I'll add 6. And I'll get x equals 6. So I have my 2 solutions. All right, I got a couple for you guys to try on the next page, so go ahead and give those a shot. and then we'll take a look at them in a few minutes. All right, so for number 1, we want to, it's very similar to the last one we just did actually. What is our common denominator here? 6, yes. Okay, so we're going to multiply everything by 6. And there we go. Okay, so these 6's here cancel. So we get z squared. Here I have 2 goes into 6 3 times. So I'm going to do 7z times 3, which is 21z. And that is a minus. And 12 times 6 is 72, I believe. 0 times 6 is 0. All right, so we have a monic trinomial. We have a negative 72, so I'm going to look for factors that have a difference. So I'm going to subtract. Okay, so what factors of 72 did anyone find? Add to 21. 3 and 24, that's good. Am I going to do 3 minus 24 or 24 minus 3? It's a negative 21. 3 minus 24, so positive 3 minus 24. 3 minus 24 will give me negative 21. 3 times negative 24 gives me that negative 72 there. And then I'm going to take each factor and set it equal to 0. Okay, so here I'll subtract 3. And this will give me z equals negative 3. And here I'm going to add 24. And I'll get z equals 24. So I have my two solutions, negative 3, positive 24. And I'm just going to warn you guys right now, be careful on the test, because if negative 3 and positive 24 is one of the answer choices, what's the other one? Positive 3 and negative 24. So really careful when you're on the test there. I know you guys are like, yay, multiple choice, but sometimes that can bite you in the butt because you're like, oh yeah, those are the numbers. Looks good. So be very careful. Okay, so let's look at this next one. Let's go ahead and move the 72x over. So I'm going to subtract that. So I'm going to have 2x cubed minus 72x equals 0. Is there a GCF there I can take out? 2x, yeah. All right, so I take that 2x out. 2 divided by 2 is 1, x cubed minus 1, so x squared. 72 divided by 2 is 36. These x's cancel. All right, can I factor x squared minus 36 further? Yeah, I can. 36 is a perfect square, isn't it? So that's x plus 6, x minus 6, which makes the middle go away. 6 minus 6, 0. 6 times negative 6, negative 36. So then I'm going to take each factor, set it equal to 0. So I get 2x equals 0. Divide by 2 there. That's going to give me x equals 0. X plus 6 equals 0. I'm going to subtract 6 here. That's going to give me a negative 6. And then x minus 6 equals 0. I'll add 6, and that'll give me x equals positive 6. So I get 3 answers there, 0, negative 6, positive 6. All right, and then number 3. What do we want to do first here? Distribute. Yeah, so negative 3 times y, negative 3y. Negative 3 times negative 2, positive 6 plus y. 5 times 3 is 15. Negative, or 5 times negative y, negative 5y. This isn't quadratic. This is actually linear. So you could solve this like a normal problem. But since we're actually doing the factoring, we are going to solve it by factoring. All right. So let's go ahead. This side, we got to combine like terms. So negative 3 plus 1 gives me a negative 2y plus 6 equals 15 minus 5y. So this means I'm going to move everything to one side. So I'm going to take the minus 5y, I'm going to add it. I'm going to take the 15 and I'm going to subtract it. Okay, so everything on this side just zeroes out. And then here I have negative 2 plus 5 is 3y, and 6 minus 15 is negative 9. Now, a lot of you are going to be tempted to add the 9 and then divide by 3, which is fine, you can. I'm not saying you can't do that. If I want to solve by factoring, I could also do that. Okay, so here I could take a GCF of 3 out of here. Okay, and that's going to give me 3, and then 3y divided by 3 will give me y, and then 9 divided by 3 will give me negative 3. And then I'm going to take each factor and set it equal to 0. So I have the factor 3. I'm going to set that equal to 0, and I have the y minus 3. I'm going to set that equal to 0. So if I have a GCF that's just a number, that gives me a false statement. So that ends up just being thrown out. 3 doesn't equal 0. Okay, now if it was 3x or 3y equals 0, then we would solve it. But in that case, it's just the number. 3 does not equal 0. We just throw it out. And then here we add 3. So you can get y equals 3. So a linear equation can be solved by factoring, but it is actually the hard way of solving it. Probably easier to solve it like a normal equation. And that should be everything for this section.